Hello, welcome back to Cinderella Math. Today's lesson is going to be on multiplying and dividing proper fractions, improper fractions, and mixed numbers. I already have a video on the channel for adding and subtracting. In my opinion, this is easier. So you wouldn't think that. You would think that adding and subtracting is an easier process, but actually I disagree. I think you'll like this, and I'm going to be doing everything by hand. If you would like a calculator, feel free to grab one. And yeah, we're going to go ahead and just get started with multiplying and dividing. Actually, this should just say multiplying. Mm, well, okay, that's fine. Let's just do multiplying proper fractions first. Just mislabeled my things. It's no big deal. Maybe. Let me just get back to that slide there. Alrighty. So let's start with just proper fractions. So proper fractions means the top is smaller than the bottom, right? So a half, that's proper, times a third. Both of those are proper fractions. That's going to be my example one. And all you do for multiplying is you multiply right across the top, right across the bottom. I'm using the dot for multiply. Perhaps if you're in middle school math, you maybe still use the X. So if you see 1/2 times 1/3, that's fine. Just as you move higher up in math, we get away from using the X because once you hit algebra, the X is an unknown that you solve for. So I've been an algebra teacher for many, many years, so I don't really use the X for multiply, though you can. So if that's what you're more comfortable with, the dot means the same thing. And there is actually a third way to show multiply, and it's just 1/2 times 1/3. So when something's by itself in parentheses, this means these are being multiplied. So all three of those problems that I have written there are completely the same. They look different using different notation, but they all mean to multiply 1/2 times a third. I'm going to try to stick to the dot for today's lesson, but again, if you don't like that, feel free to change it to the X. Go right across the top. So 1 times 1 is 1, right across the bottom. 2 times 3 is 6. If you can reduce, reduce. That one doesn't, you're done. Okay, example 2. How about 4/9 times 2/5? Right across the top would be 8. Right across the bottom would be 45. Check and see if it reduces. It doesn't. You're done. Sample 3. Let me see if I can think of one that would reduce. Let's do 2/7 times. Think of something here. 1/2. That should work. Go right across the top, so that would be 2. Right across the bottom, that would be 14. Now, those are both even. So even though that is a correct answer, it's not the best answer. Let's reduce or simplify by dividing by 2, which is 1, dividing by 2, which is 7. That would be the best answer there. And that's all you do. If you have proper fractions, which again means the numerator is less than the denominator, you just multiply across the top, multiply across the bottom. There is a way to do example 3 differently. I'm not going to do it in today's video. It's a bit of a shortcut, but for today, I'm going to assume we're just learning how to do this for the first time. And I'm still on the wrong slide, aren't I? Keep clicking the wrong thing, but we were just doing proper fractions. Now we're going to multiply, not mixed numbers. I keep hitting the wrong button. We're going to multiply just improper now. Back to there. There we go. All right, again, those were all proper. Let's switch to improper, and it's actually going to go very similarly. So improper is like when is definition is the top, the numerator, is greater than the denominator. So like 6/5. That is an improper fraction. We could turn it into a mixed number, but don't. We prefer the improper. Just like if you've watched my adding and subtracting video, we preferred the improper form there. We prefer it today as well. So I'm going to do 6/5, which is improper, times 4/3, which is also improper. Go right across the top, which would be 24, right across the bottom, which would be 15, and then ask yourself, can that reduce? Yes, because you can divide by 3, which is 8, divide by 3, which is 5, and then that's your answer if your teacher or your worksheet or whatever you're doing says that you can leave it improper. If you are in high school right now and you're watching this as a review, just to like really get good with your fraction skills, or maybe it's been a while and you're just doing this to brush up as you head into high school, or maybe you're even, brushing up before the SAT or whatever. Usually in high school, we leave this. Okay, for my middle school folks, sometimes you'll be able to leave that, and then sometimes your teacher or worksheet or whatever you're working on will want it as a mixed number. So it just depends on what you need done. If you can leave it improper, you're done right there. If you need the mixed number, we're going to divide 8 divided by 5. Goes in once with a remainder of 3. So the whole number is always up here. Your quotient is your whole number. The remainder is your numerator. And you're always going to leave the same denominator. So see how it had a denominator of 5? It still does. This is still your denominator. So 8/5 is your improper answer. 1 and 3/5 is your mixed number. They are the same thing. So again, just follow your teacher or your worksheet or whatever to see which answer is best for you. And again, there is another way to do that with a little bit of a shortcut, but I'm not going to show that right now. Maybe I'll show it at the end of the video. But again, I'm just assuming that this is your first time doing this. And if it's not, maybe fast forward to the end and I'll show a shortcut. Example 2, let's do a proper fraction, 3/8 times an improper 10/7. Right across the top would be 30. Right across the top would be 56. Those are both even, so we definitely can cut in half, so that's 15. Cut in half, so that's 28. And I think that's the best we can do. That now we don't have to do the mixed number thing on that because 15/28 is proper. Only impropers get converted back to mixed numbers, so we do not have to worry there. Okay, and that's how you do multiplying with improper. Really the same thing, right across the top, right across the bottom. Simplify if possible. Okay, let's go on to the dividing. So let's just do dividing proper for now. Example 1. Let's do 1/2 divide 1/4. Okay, so take a second here. Let's think of a pizza, and we have a half. Let me grab my highlighter. Okay, so this green part, that's the part of the pizza that's still in the box. I don't know why I colored a pizza green, but let's just pretend. Okay, and we are going to chop that portion into fourths. Okay, so 1, 2, there we go. Okay, 1/2 chopped into fourths. Okay, so for the actual arithmetic part of this, we actually don't divide fractions. There is a trick, and it's called keep, change, flip. Let me write that out for those of you who like to take good notes here. Keep, change, flip, and this works for division. So what we're going to do, we're going to keep that first fraction a half, change the division to a times, and flip the second fraction upside down. The fancy name for a flip of a fraction is a reciprocal, just in case you see that in your textbook or your teacher says it in class. We're taking the flip or the reciprocal. So that would be 4/1. Go right across the top. 1 times 4 is 4. Right across the bottom, 2 times 1 is 2. You could divide by 2, which is 2/1. But what is 2 divide 1? Just 2. Okay, I probably didn't need the pizza illustration there. Let me show you one more. So really, every single time you get a division, you're going to change it to a multiply. Okay, let's try that again. Example 2, let's do 9/10 divide 2/5. We're not actually going to do that problem. We're going to keep this one. So we're going to keep the 9/10, change this to a times, flip this one upside down. Okay, so that's why I had to teach you multiply first, because every single one of these division problems is going to turn to a multiplication. Go right across the top, 45, right across the bottom, 20. Those can both be divided by 5, so let's reduce. That would be 9/4. That's your answer if you're allowed to use improper. Or we can come over and do 9 divide 4. That goes in twice. There we go. So that would be 2 wholes and 1/4. So either way is fine. There's your improper, there's your mixed. They're both correct. It again will just depend. And that's how you divide proper fractions. The improper is going to go the same way. So now I'm going to switch over to dividing improper fractions. Example 1. Let's do 11/4 divide 5/2. They're both improper, but it really doesn't matter. You do not want to turn these back to mixed. Just like with the multiplying, you're going to leave them as improper. And then just like previously, whenever you see the divide, we're going to do our new strategy here. Keep, change, flip. And again, I'll write that out. So keep the first fraction, 11/4. Change the division to a times, and flip the second fraction or do the reciprocal of the second fraction, which is 2/5. Right across the top would be 22. Right across the bottom would be 20. They're both even, so let's divide by 2, and we get 11/10. Answer if you're allowed to keep it improper, or we can divide it out. That's 1. So that would be 1 and 1/10 as your mixed. Either one's fine. Let's do one more. All right, let's do 7 divide 8/3. We need the 7 to look like a fraction. So anytime it's just a whole number, we know there's an invisible 1. Okay, lots of times in math, we get these invisible, or what I like to call ghost ones. And now we can do it. Keep, change, flip. So keeping the 7/1, changing the division to a times, flipping the other one upside down. Right across the top would be 21. Right across the bottom would be 8. That does not reduce, so that's your answer if you can leave it improper. Or we can come over here. 21 divide 8, that goes in twice, so the whole number is 2. And that would be 5. So 2 and 5/8. Either way is correct. Okay. All right. So that was with multiplying and dividing with proper and improper fractions. It's really not too bad. Remember with the dividing, you're going to keep, change, flip. It does get a little more annoying if you've got the mixed numbers. So let's talk multiplying mixed numbers. There, I'm actually on the right slide now. Oops, no, I'm not. Why does it keep doing that? There we go. Example 1. So we're back to multiplying. Let's do 3¼ times 1 and 2/3. Okay. Step 1 is going to be to convert everything to improper. So let's do our little trick. If you've watched previous fraction videos with me, we take the bottom, multiply the whole number. So 4 times 3 is 12. Hold that in your head and then add the top. So that's going to be 12 plus 1. So that's 13 over 4 times, and let's do the same trick. 3 times 1 is 3. Hold that in your head. Plus 2 is 5. And then you keep the same bottom. And now you're ready. Go right across the top, 65. Right across the bottom is 12. I don't think that reduces. So that is your answer if you leave it improper. But since the original problem had mixed, we probably want to convert it back to mixed. So step 2 was just to multiply the impropers. Reduce if possible. This one did not reduce, or simplify, whatever you call that. And step 4 is most likely convert back to mixed number. And usually, again, we just do that. If the original problem was mixed number, it would make sense to put the answer back to a mixed number. So if we're going to do that, we'll come off to the side here and do 65 divided by 12. That goes in 5 times, which is 60, with 5 left over. So the whole number is 5, top is 5, and denominator is 12. So there's the improper answer, which is correct. And then there's the mixed number, which is also correct. But probably we want the mixed number here since the original problem was a mixed number, was 2 mixed numbers. All right, I'm going to leave the steps up there. And let's go for example 2. Anytime I'm going too fast or you're still writing stuff down, just push pause. There's also the speed control on YouTube. You're welcome to slow me down or speed me up. Example 2. What if we just have 9 and 2/5 times 1/4? So one of them's a mixed number and one's just a proper fraction. That's fine. We're actually just going to leave the 4th. He's good. And we need to convert the mixed number to improper. 5 times 9 is 45, plus 2 is 47. Keep the denominator. Right across the top is 47. Across the bottom is 20. That would not reduce. Answer if it's improper, if you're allowed to leave it improper, but we will go ahead and convert back. So 47 divide 20, that goes in twice. And there we go. So that would be 2 7/20. And that's all you do for mixed numbers. You convert them to improper and then do it as normal. Let's go to dividing mixed numbers. All right. Example 1. Let's do 3.5 divide 1 2/9. Okay, step 1 is going to be the same as before. And when we had the multiplying mixed numbers, we are still going to want to convert everything to improper. Okay, so let's do that. 2 times 3 is 6, plus 1 is 7. Keep the denominator. Divide. 1 times 9 is 9, plus 2 is 11. Keep the denominator. So there we go. We converted to improper. And then step 2 is going to be that same method we used for dividing the regular fractions. We're going to keep, change, flip. Keep, change, flip. Change to times, flip, or the reciprocal of the second one. Go right across, that's 63 over 22. That would not reduce. That's your answer if you're leaving it improper, so then we just multiplied. And now we probably will need to convert back to mixed. And why again? Because the original problem was given as mixed numbers, so they probably, the teacher or the worksheet, whatever, probably wants the answer back as mixed number. So we'll just come to the side here, 63, 22. That goes in twice, which is 44. There we go. So that would be 2 19 over 22. There we go. There's your mixed answer. Okay, I'm going to do one more here. Let me leave the steps up. And then I will show you a shortcut trick for the multiplication. But it's not a necessary trick. So if you're like, okay, I'm good at what she's already showed me, I understand it. If you want to turn off the video after this next example, feel free. But I will take a second and show a trick. And it's a nice trick and it does come in handy. So it's good to know. I wouldn't say you have to know it, but it is nice. So one more though on dividing mixed. Let's do 10 divide 4 1/4. Now remember there's an invisible 1. Okay. So that's 10 over 1 is already good, so he's fine. Divide, and let's turn the other one to improper. So 4 times 4 is 16 plus 1, so 17. Keep the denominator. So there's that. Now we're going to keep, change, flip. Keep, change, flip. Keep, change, flip. Right across the top would be 40. Right across the top, or excuse me, right across the bottom would be 17. That's your answer if you leave it improper, but we will come off to the side. 40 divides 17 goes in twice. So this would be 2 6/17 as the mixed. Okay, and there we go. In my opinion, that's so much easier than adding and subtracting the fractions. Again, I do have a video on that as well, because you don't need a common denominator. That whole step is just not here in this lesson. All right. If you want to sign off now, you can. I will take a second and show you a shortcut on the multiplying. And now this shortcut doesn't always work, but when it does, it can save you time. So I'm going to call this a cross cancel multiplication shortcut. And again, it doesn't always work. So example 1, let me show you an example. It does not work. So if it's just 1/3 times 1/4. What I mean by crossways is kind of diagonal. So see the 1, oh, let me get a different color. See the 1 and the 4. You're looking for that kind of crossways, that diagonal, kind of like you're playing tic-tac-toe there. You're looking for that to have a common factor that you could divide out. Well, there is no common factor from 1 and 4. One's, just 1. No, there's never going to be a common factor with 1. So that's not going to work. And then you also look at the other diagonal, so kind of the other tic-tac-toe, and you got 1 and 3. There's no common factor there. Again, you're never going to have a common factor with 1. So this one, you have no shortcut. You just go right across the top, right across the bottom, and you get a 12th. So that one, nothing could have been easier. Let me tweak just one thing. So I'm going to keep the third, but I'm going to change the other one to 9/11. Now look crossways, 1 and 11, no, they still don't have anything in common. Again, a 1 never will. But look the other way, 9 and 3, what do they have in common? You can divide by 3. So you're kind of like reducing or simplifying within this crossways. So divide by 3. 9 divide 3 is 3. So take your 9, scribble it out, and put a 3. And do the same thing with the other crossway. So the other number there was 3. 3 divide 3 is 1. Take it, scribble it out, and write a 1. And now go right across the top. 1 times 3 is 3. 1 times 11 is 11. Answer. Now you do not have to do that. Let me put the same question up here. It was 1/3 times 9/11. Go right across the top is 9. Right across the bottom is 33. And then you just have to catch that that reduces. You can divide by 3, which is 3. Divide by 3, which is 11. Answer. Same answer. Personally, I think the cross canceling saves me time. It does take a while to get good at that cross canceling, but I think it's worth it in the long run to learn it because it will save you time. Do you have to do it? No, you certainly don't. Let me show you a couple more examples here. Let's say example 3. 5.5 times 1.25. Okay, we still need to convert those to improper. 10 plus 1, so 11 halves. Is that going to work? Sorry, don't know if that's going to work. Well, it's fine. It's still a good example of when it doesn't work. So that's 11 halves, and that's 5/4. No, this one's not going to work. And how can I tell? 11 and 4, there's nothing in common. 5 and 2, there's nothing in common. Let me make this 1 2/4. There we go. Now let's convert. That's still 11 halves times 6/4. This will work. All right, this first crossways, 11 and 4, they don't have anything in common. So that's okay. Let's check the other way. 6 and 2, they're both even. You can divide by 2. 6 divided 2 is 3. Cross it out, put a 3. 2 divide 2 is 1. Cross it out, put a 1. Now, right across the top, 3 times 11 is 33. 1 times 4 is 4. There's your improper answer, or you can just come off to the side. That's 8 1/4 mixed. And again, this will save you time once you're good at it. It saves you from having to reduce at the end. You're basically just reducing in a different spot. Okay. Does it work with division? Sure, because we changed division to multiplication. So let's say we have, well, let me try one on a piece of paper first so I don't get one that doesn't work here. Okay. So let's do 6/10 divide a fourth. So this is just regular dividing. 6/10 divide a fourth. Keep, change, flip. And then if you check crossways, 6 and 1, they won't have anything in common because again, nothing will with a 1. And this way, 10 and 4, well, they're both even. 4 divide 2 is 2. 10 divide 2 is 5. Now you can go across the top. 6 times 2 is 12. And across the bottom, 5 times 1 is 5. Answer, if you can leave it improper, or, whoops, 2 2/5 if you have to convert. So it still works because all division is going to turn to multiplication with our keep, change, flip. So again, that's how you can cross cancel. It's not always there, but when it is, I do think it saves some time. Let me try to just think of one that's got, this won't be a division, but let's see. What if it is 9/10 times 15/6? Right? Look crossways. 9 and 6, you can divide by 3. 9 divide 3 is 3. 6 divide 3 is 2. And now let's look other crossway. 15 and 10. You can divide by 5. 15 divide 5 is 3. 10 divide 5 is 2. Right across the top, 3 times 3 is 3, or 9. 2 times 2 is 4. Answer, if you leave it, is improper, or 2 1/4 if you have to convert it back. See, that just helped my mental math too. Let's go back to that original problem. 9/10 times 15/6. If I just went straight across the top, I don't know what 9 times 15 is. I could figure it out, but it's going to take me a minute, right? Or I can grab a calculator, which is fine. But if I'm all about speed here, if this is like a timed situation, I want to go as fast as I can. Yeah, I know what 10 times 6 is, but I do not know 9 times 15. So this trick could also just end up saving you time, right? That's honestly what it is. It's a time saver. It's not an essential trick, but again, I think it is a nice one to know. All right, that's going to conclude my lesson on multiplying, dividing fractions, including proper, improper, and mixed numbers. I hope this was helpful to you and that you're having a great day. And I hope to see you back soon on the channel. Bye bye.